Special guest, talk to the people.
Hi everyone, it's Mr. Grimmer from Larbert High School here. Best of luck with all your maths work this year. Behind PE, of course, being my favourite subject, when I was at school myself, maths was my second favourite subject. So best of luck this year with your maths.
Thanks, Mr. G.
It's time for Maths with Mr. Thomas.
Let's go with chapter 6, lesson number 5. We're now moving on to look at the magnitude of a vector. Quick reminder, what is a vector? Help me out, Sophie. Brilliant, yes, a vector is a quantity that has both size and direction. For example, gravity. We know gravity acts on pretty much everything here on Earth, and gravity has a number, it's got a size attached to it. We know it's 9.8 meters per second, and there is a direction, it's pulling everything in towards the center of the Earth. Something else that we have is the force applied to anything. An example here could be a snooker ball. Obviously, you're hitting that snooker ball with a certain strength, a certain force, and there'll be a direction attached to that as well. If April stood up and we pushed April, well, April is going to fall backwards. So there will be a force there. A certain strength, so there's a number, but there's also a direction. Velocity is also a vector. There is a size and a direction. For example, the velocity of the plane might be flying at 400 miles per hour in a bearing of 10 degrees. However, we are not always interested in the direction. Sometimes we may just want the size or the strength of the vector. For example, we just may want the length of the line. The direction may not interest us at all. With this vector here, we've been drawing vectors out a few lessons ago, and we can see it looks something like this. However, as I said, we may not be interested in the direction. We may just want the size of it, or in other words, the length of the line in this case. Or we just may want to know the strength of the force. What was the force applied to the snooker ball? Again, forget the direction, just how many newtons was it hit with? Or we may just want the speed of an object. We may just want to know that the plane is flying at 355 miles per hour, but the direction may not be important to us. So if we are only interested in the size and not the direction, well, what we would have then is a scalar quantity. A scalar, remember, is a quantity with a size but not a direction. So if we have a vector but we're not interested in the direction, then that number associated with that will represent just its size. Or in other words, its magnitude. The magnitude is the size of the vector. Let's try an example. So the magnitude of a vector is its size or its length. If we've got this vector here, AB, let's just call that vector U. Let's say it has the components 4, 3. If we draw that vector, it will look something like this. We can see for this vector, if we've got a starting point A, we came along 1, 2, 3, 4 boxes, then we went up 1, 2, 3, so that is the components. 4 along the x-axis, 3 up in the y-axis. It's got the components 4, 3, but that's not the vector. This line here with the arrow, that is the vector. What we want to do though is we want to find out the length of this line. We're looking for the size or the magnitude of the vector. How could we go about doing that? How could we work out the length of that line? Help me out. Lindsay? You're a genius. Well done. When I just drew that on there and there, we can see we went along 4 boxes. We went up 3 boxes. What does this remind you of? Pythagoras! Yeah. Pythagoras' theorem allows us to work out the length of the hypotenuse in a right-angled triangle. If we draw on these components, the 4, 3, going along 4 and up 3, what we end up with, if the vector is drawn in as well, is a right-angled triangle. So to work out the length of that line, we just use Pythagoras. Thank you, Pythagoras. No problem. So, if AB has the components 4, 3, the way we work out the magnitude, or size, or length of that vector is by doing... Yeah, it looks just like that. What we would do is this length squared, so u squared would be the same as 4 squared plus 3 squared. And then we would square root it. So the way we write it out is we just take the square root of the 4 squared plus 3 squared. And what you'll notice is there are these funky wee lines either side of vector AB or vector U when it is written. Those lines are known as the modulus sign, and they are used when we are wanting the size of the vector. So if we have AB without the modulus signs, then we can write that just in component form with the brackets here with our x component and our y component. If we've got these lines either side, that means we're going to work out the size or the length or the magnitude of the vector. Let's try some examples with that. So example 1, calculate the magnitude of vector CT. You can see that CT has the components -5, 12. So, James, how do you go about working out the magnitude? Well, first of all, you would have to write down CT with the modulus sign. Perfectly right, yes, you'd have to write down CT. This is vector CT, and we've got the modulus sign, which means we're going to work out the length of CT. In order to do that, how can we do it, princess? Yes, very well done. What you will do is you will take the square root of, and we take each of these components and square them. So it's the -5 squared plus the 12 squared. Woo! If you start working that out, we've got the square root of 5 squared, or -5 squared, gives us 25, and 12 squared is 144. Add them together and you get the square root of 169. The square root of 169. Go on, Brainy. Yeah, it is 13. And remember, because it's the length of the line, it's the size of the line, it's the magnitude of the vector, you end up writing units, because the length is going to be measured in something units. Centimeters, meters, kilometers, whatever it may be. So we write in the word units to show that the length is going to be measured in something, and whatever it is, it's 13 of them. Example 2, calculate the magnitude of vector NM, which has components 11, -3. So, Fran, help us out. Brilliant, you'd have to have the modulus signs. Good, because you've got NM, that is the vector, and the modulus signs means we're going to work out the size. So to work out the size, we would, help us out, what would you do, Anne? Brilliant, it is the square root of the 11 squared plus -3 squared. Working that out, 11 times 11 is 121. Well done. And -3 squared is, well, -3 times -3, two negatives make a positive. So it will be 121 plus 9. Very well done. 121 add 9 is obviously 130. We're still wanting the square root of that. If you stick that into your calculator, you end up with, 11.4. And once again, the size, the length is going to be measured in something, but you don't know what the units are, so write in the word units. And that is your answer. Woo! Ahmad, whose brother sent me an email. How you doing? Let's try example 3. Calculate the magnitude of the vector joining point E, which has coordinates 3, -5, and F, which has the coordinates 9, -13. What is the first thing you would have to do, Ahmad? Brilliant. You would have to work out the vector joining E to F. So to work out the vector joining E to F, do you remember how to do it? Brilliant. It's the second, take away the first. This is what we were doing in the last lesson. So it's vector F minus vector E. Vector F, well, because it is the point 9, -13, the position vector from the origin up to F will have the position vector 9, -13. And if we're taking away E, we would be taking away the position vector of E, which will be 3, -5. If you work that out, go on, Ahmad. This is your example. Yeah, you got it. 9 take away 3 is 6, and -13 take away -5 would be -13 add 5. -13 add 5 gives you -8. Woo! Ahmad, you're halfway there. You're perfectly right. What you do next is work out the length of that line. So to work out the length, bring in the modulus sign. You know we're going to have to work out the size of this vector. So we've got vector EF. Modulus signs would be the square root of, because this is the components of the vector EF. We're going to have the square root of the 6 squared plus negative 8 squared. So that becomes the square root of 6 squared, 6 times 6 is 36, negative 8 squared, negative 8 times negative 8, two negatives make a positive, so that'll be plus 64. 36 add 64, Ahmad, you've got it, it is 100, and the final word to you, once again, Ahmad, you got it. Yes, it would be 10. 10 what? Units! It is 10 units. Very well done. High five to Ahmad. Example 4. Calculate the magnitude of the vector joining B, negative 6, 0, and P, 2, 9. So, how would you start this one off? Yes, similarly, you want to work out what the vector would be. It's asking you, calculate the magnitude of the vector, so we need the vector. So let's just get the vector B, P. We could also work out P, B. It doesn't really matter, we're just wanting the vector that joins those 2 points. It doesn't matter the direction. Remember, it's just the magnitude we want. The direction is not relevant. If we worked out B, P, that would be P take away B. And that means then, well, P would have the components 2, 9, and we would take away B, which is negative 6, 0. 2 take away negative 6 gives us, brilliant, and 9 take away 0, you got it. That is going to be the vector BP, but we want the magnitude of that vector. How can we do it, Colin? Yes, we will take the square root of the 8 squared plus the 9 squared. But how do we write that out? You use the modular sign. Yeah, you're perfectly right. So we'll have BP, and then that equals, and we've got the modular signs here. We've got the arrow drawn in to show this is the vector BP. And that will be the square root of 8 squared plus the 9 squared. Which means then that is the square root of 8 squared. Good. 9 squared. Good. And if you add them together, good. If you take the square root of 145, just work that out on your calculator, you end up with, yeah, it is 12.04 to 2 decimal places. And once again, that's going to be a length. It's measured in something. We don't know what it is, but put in the word units to show that we remember it will be measured in something units. 12.04 units is the answer. Example 5, calculate the magnitude of the vector joining M and L. So to do this, well, M is the point 7, negative 4, and L is the point 1, negative 7. First of all, we need a vector. We need a vector joining those 2 points. So we can either work out ML, or we could work out L back to M. It doesn't really matter which way around we do it, because again, the direction's not important. It's just the magnitude or the size. What I've done though is just worked out ML. If you do it the other way around, you will get the exact same length. So working out ML, that is going to be L take away M. And L is 1, negative 7. And we are taking away M, which is 7, negative 4. Woo! 1 take away 7, yeah. And negative 7 take away negative 4. It's negative 7 add 4, which gives you negative 3. Well done! So, ML is the vector negative 6, negative 3. After that, Gail, what do? You do indeed, yes. In order to work out the size, we put the modular signs around this to show it's the size we're now working out. And that is going to be the square root of the negative 6 squared plus the negative 3 squared. Take it away, Holly. What would you do? Good. The square root of negative 6 times negative 6 is 36. And negative 3 times negative 3, it is 9. Well done. From there, if you do 36 add 9, you obviously get 45. And if you work out the square root of 45, go on, Octavia. Yeah, you get 6.71 to a couple of decimal places. So our answer is the 6.71 units. Woo! Yeah. Okay, so example 6, given a vector u is 5, negative 2, calculate the magnitude of 3u. So 3 times the length of vector u. What do you think the first thing we would have to work out is, Liz? Yeah, we would have to work out what 3u is. So that is just going to be 3 times by vector u. So it's 3 times the 5, negative 2. In order to work that out, just multiply each of these numbers by 3. So 3 times 5 gives us 15, and 3 times negative 2 is negative 6. That is the vector 3u. Michael, what do you think you do after that? Brilliant. You then just work out the magnitude of that. So write down 3u, put the modulus sign at either side of that, and then you're going to have, well, to work out the size of it, it's going to be the square root of each of these numbers squared and added together. So it's the 15 squared plus negative 6 squared. 15 times 15 is 225. Negative 6 times negative 6 is positive 36. Add them together, and Maria, you get? Good, you get 261. Take the square root of 261 and you end up getting 16.16 units. Woo! Example 7. Calculate the magnitude of the resultant vector of these 3 vectors. We've got 10, negative 3. Add on negative 1, 5. Take away negative 7, 4. How do we work out the resultant vector? Buffy, what do we do? Brilliant. Yeah, we would just add these two together and then take away this one. Really, we're just going to work out what that would be. So we would do the 10 add negative 1, take away negative 7. And then we do the negative 3 add 5, take away 4. If you work that out, you end up getting, what would you have at the top? Go on, Xander. Yeah, you would end up with 16. And Giles at the bottom. Brilliant. You'd end up with negative 2. Woo! After that, Willow, what do we do next? Yeah, well, we're wanting the magnitude of the resultant vector. We have found this resultant vector. The resultant vector is this one here. But we now want the magnitude of that. So to get the magnitude, we would take the square root of, and then we take both the x and the y component and take the square of them and then add them together. So we do the 16 squared plus negative 2 squared. 16 times 16? It is 256, well done. And negative 2 times negative 2, it is 4, good. Add them together and you get 260. And from there, what do you do next? Go on, Oz. Yeah, to take the square root, so you end up getting an answer of 16.12 units. Yeah! Final example, example 8. Given these two vectors, we've got vector g, which has components negative 7 and 1.5, and vector h, which has components 0, 8. What we're asked to do is work out the magnitude, that's what these lines mean, the magnitude, the size, the length of the vector, and we've got the magnitude of 2g take away 5h. So the first thing we have to do is ignore the modulus sign. Just work out what this vector would be. How do we get the 2g take away 5h? Well, 2g means we're going to have 2 times vector g. So it's 2 times the negative 7, 1.5. And we would be taking away 5 lots of vector h, which is the 0, 8. From there, well, 2 times vector g is 2 times the negative 7 and 2 times the 1.5. So we'd get negative 14 and 3 because we multiply both of these numbers by 2. Then we take away, and if we multiply the 0 and the 8 both by 5, we would still have 0 in the top, but we would have 40 on the bottom. One vector minus the other, well, just subtract the x components and then subtract the y components. So negative 14 take 0 is still negative 14, and 3 take away 40 is negative 37. So that is the vector 2g take away 5h. We've got that vector, but now we want to work out the modulus of that. We're wanting the size of it. We're wanting the magnitude of it. So we've got the modulus signs. And how do we work out then the magnitude? Brilliant. We take the square root of both the x component squared, so negative 14 squared, plus the negative 37 squared. Woo! Work that out, and that's the square root of, well, negative 14 times negative 14 gives us positive 196. 37 times 37, everybody knows that. It is the 1369. And then if you add them together, you get 1565. Taking the square root gives you an answer of, go on, Tom. Brilliant, you get 39.56 units. Woo! That is a lesson on how to work out the magnitude of a vector. Just remember, it's really Pythagoras' theorem in disguise. If you know the components of the vector, well, you would just do the square root of the x component squared plus the y component squared. Good luck with some of these questions. Some can be found in the TJ National 5 book, page 147, exercise 15.4. Best of luck, have fun. Anything else to say, Mr. G?
Best of luck this year with your maths.
Bye.